This video is on special relativity. It is based on my book Pondering Relativity, an illustrated guide for building an understanding of Einstein's relativity. My name is Doug Funky. I'm a certified professional ergonomist, and my book uses human learning principles to make relativity understandable. Special relativity is the first of Einstein's two theories of relativity. It is based on two very basic principles. One, all motion is relative, and two, the speed of light is constant, or what scientists call speed c, or 186,000 miles per second. The first principle, all motion is relative, is really quite obvious. For example, if you're walking down the aisle of an airplane, you're moving at, say, 2 miles per hour relative to the inside of the airplane. But if you realize that the airplane is also moving across the surface of the earth at, say, 500 miles per hour, you're moving at 502 miles per hour relative to the earth. But the earth is also orbiting around the sun, and the sun is orbiting around the center of the Milky Way. So if you were to pick either of these frames of reference, you'd be moving at a much faster rate. And this complicates the measurement and calculation of speed and distance. For example, dropping a ball from outstretched arms on a train car, the ball would go about 3 feet, take about a second, moving at 3 feet per second. But if you were to observe this event from the side of the tracks as the train car moved past, the ball would appear to move, say, 4 feet and take a second or move at a speed of 4 feet per second. And this phenomenon is also true of light. In this example is one that Einstein used in his book. If you were to shine a light from the ceiling of a train car to the floor of the train car and reflect it back to the top, the photon would move a distance of 2 times the height of the train car. But again, if you were to observe this event from the side of the tracks as the train car moved past, the photon would appear to cut a much longer pathway, a longer distance, compared to how it is experienced on the moving train car. Now, the second principle is that the speed of light is constant. It's always what scientists call speed c, or 186,000 miles per second, regardless of any relative movement to the source of the light. So in this example, with the Earth moving away from a distant star, and when it is moving towards the star, the speed of the light approaching the Earth is the same. This is not intuitive, this is not obvious, but it is what scientists measure. It's been measured and documented again and again and again, and it is how light works. The speed of light is constant, regardless of any relative movements. So how does this work on the moving train car? In this case, the light appears to take a longer pathway as viewed from the side of the tracks compared to how it is experienced on the train car itself. And Einstein's solution, Einstein's answer to this, is that it is time itself that moves more slowly on the moving train car. That is, time moves more slowly on moving platforms to account for the shortened pathway of light as experienced on those moving platforms, sometimes referred to as compressed space. Time on moving platforms moves more slowly. The mnemonic that scientists use to help us remember this is that moving clocks run slow. Moving clocks run slow to account for the shortened pathway of light as experienced on the moving platform, or sometimes referred to as compressed space. Moving clocks run slow. But with the first principle, all motion is relative, you could just as well consider the train car to be stationary. As seen from the inside the train car, it looks like the light on the outside, on the ground, is the one that cuts a longer path as the train moves past. So in this case, light appears to take a longer path as seen from the now stationary train car as compared to as it is experienced on the ground. And again, in this situation, it is the clocks or time on the ground as experienced from or as seen from the train car that moves more slowly. Moving clocks run slow. So to summarize special relativity, 1, all motion is relative, and this includes the movement of light. And 2, the speed of light is constant. Speed of light is always the same, or what scientists refer to as speed c, or 186,000 miles per second, regardless of any relative movement. Therefore, moving clocks run slow to account for the shorter distance, or the compressed space, as experienced on the moving platform. Again, this is based on my book, Pondering Relativity, an illustrated guide for building an understanding of Einstein's relativity. I hope you'll get a copy. It has illustrations throughout the book so you can see how relativity works. And it is available at Amazon, or you can visit my website, ponderingrelativity.com. Thank you.